All right, today's lesson is on functions. It's section 1.2 in the pre-calculus book. Well, there's relationships, there's relations and functions. All functions are relations, but not all relations are functions. A relation are two quantities that are related to each other by some rule. I think of the time of day and the temperature outside, the quarterback's name and the number of passes he's made. They're related, but there's no rule to follow. A function is when you have two sets of data and there's only, the best way to say it is there's one y for each x. Or an x can't have two y's. All right, if you think about graphing it, if x is equal to 1, you can't have a y value here and a y value here. The vertical line test, we've done that before. All right, domain is the set of all inputs, the independent variable. Usually it's x. The range is the y, all the output values. We usually call that y. A function defined by two or more equations over a specified domain. A piecewise function usually looks like this. It'll be x plus 2, and it'll be x is less than 0. You might have x minus 5 from 0 is less than or equal to x, which is less than or equal to 2. Okay? That's a piecewise function. We do a lot with those this year. In your own words, what's a function? A function is when every x has only one y. One y. What is not a function? The opposite. In your own words, when is a function undefined? If you divide by 0, or a negative under the radical. I hate writing with these pens, by the way, just so you know. All right, find the domain of the following functions. It's easier to say what values are excluded, okay? What values x can't equal is the easiest way to do it. Okay, so this problem we have two things. We have a denominator. Your denominator can't be 0. And you have a radical, and the stuff underneath that radical, x minus 3, has to be greater than or equal to 0. Okay, so the way to solve this problem is take the stuff under the radical, the x minus 3, set it greater than or equal to 0. I'm going to add 3 to both sides. And we know that x has to be greater than or equal to 3. When you write your answer, I want you to write it in interval notation, which means you start with a bracket, which means it's included, a 3, and it goes to infinity, and that's never included, so you use a parentheses. You also want to check and plug that 3 back into the problem. You end up with 15 over... Oh, we know it can't. Oh, we just found my mistake. I plugged it in. I end up with 15 over 0. You can't have x equal 3, so this has to go away. It has to be greater than 0. Okay, in this case, because it's in the denominator, it can't equal 0. Otherwise, radicals can be 0 because the square root is 0, 0, as long as it's not in the denominator. So I found my first mistake. That's a lesson to you. Go back and check your work. Okay? Another fraction. The denominator can't equal 0. X squared plus 2 cannot equal 0. So x squared has to equal negative 2. That's never possible. So this can't happen. Can't happen. So the answer is all reals. Or you say negative infinity to positive infinity. Nothing is going to make that 0. Okay? All right, next one. Oh, if I see a quadratic, I'm going to factor. You need to know how to factor to get through pre-cal class. All right? If you're not good at it, I'll find you some practice if you would like. 3 and 1 is the only way you can get 3. When you add them together, I've got to get 2, and the 3 has to be negative. So this is the negative, and this is the positive. Remember, that's the bottom of my fraction. So x cannot equal negative 3, and x cannot equal 1. If I write that in interval notation, I go from negative infinity to negative 3, then negative 3 to 1, and 1 to infinity. And you notice none of them are included. This is a parentheses. All right? And always go from left to right, small to big. This is math class. Okay? All right. Part 2. Find the following. This is written in function notation. Instead of y equals, we write, in this case, we wrote g of x equals. And they want to know what the value is when x is equal to 3. So you go over to the graph of g, you go 1, 2, 3, read up here, and the answer is 1. Okay? F of 1, the x value is 1, you run up here, and the answer is 4. F of negative 2 is here, backwards, down there, negative 1. This one is a little bit different. It's telling you the y value is equal to 3, and x is equal to, we don't know. Okay? So instead, you go on the y graph, 1, 2, 3, go over function g, and it tells you that x is equal to 4. So know how to read a graph. Plug in your x and y values. All right, evaluate. When I have a problem like this, it's got f of and a g of, I'm going to do that math first. So f of 2, I plug 2 into here. So I have 2 squared minus 1. Then I'm going to plug 2 into here, and I have 2 plus 1. 4 minus 1 is 3, minus 3, and I get 0. How much work do you have to show? You can do this in your head. You can do this in your head. But it's nice to see that this is f of 2, and this is g of 2. Okay? Now I'm going to plug in x plus 3 every time I see an x. So f of x plus 3 is equal to 1 minus 2 times x plus 3. You'll notice I replaced this x with that. I've got to replace that x also. So you get 3 times x plus 3 squared. Don't forget order of operations. You have to square this first. Okay? So this is a 1. This is minus 2x. This is minus 6 because I distributed. Don't forget to FOIL. So you got 3 times x squared plus 6x plus 9. And let's clean it up. So this is equal to 1 minus 2x minus 6 plus 3x squared plus 18x plus 27. Put them in order. Dang it, I did it again. So my answer, f of x plus 3 is equal to 3x squared. You got minus 2x plus 18 is 16x. I have 1 that's negative 5 plus 27 is 22. And that's your answer. Most common mistake on these type of problems is foiling. Okay? This is not x squared plus 9. Don't we know better than that. All right? Now, we're back to reading a graph. Okay, we read one up here. We can do it again. Hang on, let's clean up this stuff. I'm going to change colors so we know it's new stuff. All right, f of 0. Now here's 0. You go down, you get negative 2. F of 2. Now I have a problem. Is it this circle or this one? Well, that one's open, so it's not included. This is closed, so that's the answer. My domain is the x values. It's going to go from negative 3, which is included. Even though there's a gap here, there's no break in the number line, so this will go to 5, and that's also included. The range starts down here at negative 4, and it goes all the way up to positive 4. It asks us to write a piecewise function for this. You can do this a couple ways. You can write these as this is a function, this is a function, and that's a function. I'm going to get the mess out of there. Hang on. Okay, so let's write that equation. It's a line, the intercept is at -2. Oops, sorry. -2. The slope of the line is up 2 over 1, up 2 over 1, so it's -2x. And the range, the domain for that goes from -3 is less than or equal to x, which is less than or equal to 1. Then I have this line. Well, if I extend this, it goes through -6. Its slope is +2. And since we included 1 in that equation, we can't include it down here. And 2 is not part of that, so it has to be less. This one can't be equal because there's an open circle. And the last one, x is equal to 1. I mean, y is equal to 1 when x is less than or 2 is less than or equal to x, which is less than or equal to 5. Okay, another option on that is to make this an absolute value function. If you remember your transformations, the vertex shifted right 1 and it went down 4. And you could, so instead of these two equations, I could have used this instead. Something to think about. Both are correct. Okay? Graph the following piecewise function and evaluate. So let's go like this. It's 1, 2, 3, 4, 5. The slope is 2, 2, and it's less than -1. Oh, so it starts here. Then when it's equal to -1, it's at -2. So this should be an open circle. This is closed all the way over to 2, and that's open. And now I have a quadratic. When x is 2, if I plug 2 in here, you get 4 minus 3 is 1. And if I plug in 3, you get 3 squared is 9 minus 3 is 6. That's 3, 4, 5, 6. So it's a curve like that. Okay? Now, f of 2. Well, you can go up here to the equations. It's included in this one. Let's get rid of the mess. See, 2 is included right there. So the answer is 2 squared is 4 minus 3 is 1. 1. F of 3, it's also in there. 3 squared is 9 minus 3 is 6. Find x when f of x is equal to 3. I'll count on this. Oh, it's not included in this one because that's open. So you got to be this one. How do you do that? You have x squared minus 3 equals 3. Add 3 to both sides. Equals 6. So x is equal to the square root of 6. Do I need a plus or minus in front of it? Correct. No, because we only have the positive value. -√6 would be over here, and it's not in our graph. Okay? So the answer is √6. Okay, my domain, I've got an arrow over here. This was open-ended, so -∞. Is there a gap? No. It goes over here to 3, and that's included. The range is also -∞ because this arrow keeps going down. There's no gaps in my y's all the way up to this point, which is 6. Okay? All right, your homework is going to be a bunch of problems out of the book. To practice this, most of this should be review. If you have any questions, feel free to ask me. Thanks so much.